the fixheap function should be implemented as follows. So let's get a copy of the data at root. That was the copied from the last leaf onto the root. So let's keep the value in this variable root. Elements 1 is there. And then let's keep last index of the heap is elements size minus 1. The last data was popped, so it's reduced by 1. So the last index is actually this was removed. Then index of this one is a last index. It's there. Then the algorithm is promote children of removed root if they are larger than the new root which was copied from the node deleted. That's the algorithm. So currently I am at index 1. So that's the place I am here, and then I need to find the right value for here index 1. So let's begin that. Then we are going to keep repeating compare with the children and swap, compare with the children and swap, and so on. So let's begin with the infinite loop. And the professional code for infinite loop is a for empty empty. Here the second part empty is treated as true. So this is same as while true or something like that. So for some reason this for loop with empty is a preferred professional choice for infinite loop. So in the loop we will keep swapping with the children until we reach the right order and the like. So let's find I'm currently at index. Let's find the index of left child first. So child index. Let's begin with the left child index. What is the index of my left child? And if child index is greater than last index, which means there is no child. If there is no left child, then right child does not exist either. So we stop looping that. So last index was for that purpose. I am at certain location. If I don't have a left child, then I don't have a right child either. So I'm at the very bottom layer. So I don't need to do any those swapping. So that's the break condition of the loop. So otherwise, let's get the value of my left child. Child value is left child value. I am at index. So that's the value of the left child. Value of left child is this. So we compare with the left child. We also need to compare with the right child as well. So let's get the value of a left child. But if a left child is smaller than right child, we should use a right child. So after getting left child, see if right child is greater. So we need to do if right child index my right child index is within the last index. Otherwise, there is no right child. So if a right child exists and right child value, my right child value is greater than child. Their child is a child of the left child value. Then I need to use a right child instead of left. Then child index should be right child index. Instead of left, I'm going to use right child. And then value of child is also right child value. There. So this is actually belongs there. So the algorithm, what I have done so far is get the left child. If right child is bigger, use right child instead. So at this moment, the variable child has a greater of the left and right. So it should be swapped. So if child, the bigger of the two child is less than root or equal to root, then we don't need to fix. So that's the right heap. So break condition happens. If not, now promote child. So which means elements, I am at index position, and then child should be promoted, and then my new position is child index. The one promoted is my new position is there. So we loop until either this condition or that condition is satisfied. Why do I have an error here? It's expected. Oh, here the semicolon is missing in the previous line. So that's a loop condition. So we break loop if there is no more child or the child has the right value with the current root. Otherwise, swap and continue. So at the end of the loop, we found that the value root was the very first one. So the last leaf node was copied onto the root. That was root. Now we find the position for root. That is elements index. There, the root value. That was the last leaf's value is this position. So here, what I say is store root element in vacant slot. That's the last step of fixheap. In the next video, let's test comprehensively the pop function works or not.